The broadcast is now starting. All attendees are in listen-only mode.
Hey there, folks. How are y'all doing today? Can y'all see and hear me? Please raise your hand if you can. All right, excellent. So welcome to our second day of webinars. What I'm going to do today, I'm going to do a review on what we did last class, which includes making sure that everybody does have all of their accounts set up. If you were unable to attend on Monday, I'm going to send you a link in the chat to the recording that I made and uploaded to YouTube. So if you weren't able to attend, then I would like for you to watch this after class and make sure that you have all the accounts, which I'll go over, set up. You couldn't be here yesterday, but you watched the video. All right, Cameron, you're a veteran. I'm glad that you knew to watch the video. And I'm also really glad about your love of Pokemon, because I am a huge Pokemon fan. Anyways, where was I going with that? That's a good question. What we did last class essentially was just get everything set up. We made Edmodo accounts, Google Slide accounts, or not Google Slides, I'm sorry, Google accounts, and Edmodo, Google. Ideally, you would have subscribed to our YouTube channel, so in case you are unable to make a webinar, you can view the webinar via YouTube. So I started class just with, a good old, do you like these things? You'll probably like this class then. We explained a little bit of how the class works. So again, if you weren't able to show up Monday and you didn't get to watch the video, that's okay. I would like for you to make an attempt to show up to all the webinars. To those of you who didn't come Monday, I don't really like repeating myself too much. So I do like when y'all are prompt if y'all show up on time to the webinars, because it's not really fair to the other students who are on time for me to have to explain to you what to do. I digress, and I'm sorry. Again, our class meetings are going to be twice a week, Monday and Wednesday via the webinar, which is what we're doing right now. You can choose the time that you wish to attend. It'll be either 4 p.m. or 6 p.m. And every other week, so every 2 weeks, we will be having meetings, like actually meeting with each other. Those in Charlotte and Harrisburg and elsewhere will be meeting with Mr. Dubik, who is the head of Young Engineers of Today. Those in Raleigh will be meeting me. That's a good question, Una. We do not have a meeting on Labor Day. This next coming Monday, it is Monday the, 7th? We will not have a webinar. So that is a good thing. Thank you for reminding me to mention that, because I don't want people being confused as to where I am. We will meet again next Wednesday, which is the 9th. Half of Charlotte, I think, had lab yesterday. The Thursday labs obviously will have lab in Charlotte Thursday. Raleigh will have their first lab on the 12th, and Harrisburg is on the 10th. I'll need to double check that, just for future reference, so you know when your labs are. We discussed what topics we will be going over, so all sorts of different things, some civil engineering, a bunch of 3D printing. We will be using the Raspberry Pi microcomputer for this class, and we'll also be discussing some stuff about flight. So again, I know everyone knows how to raise their hands. If you're here, you have registered for all the webinars. Great deal. All right, question was, what are the limitations of the Raspberry computers? And the other question is, will we get our own Raspberry Pi? And okay, so I have several questions. I'll go one at a time. Raspberry Pi microcomputers they're very, very tiny. They can fit in the palm of your hand, and they run a Linux-based operating system. Raspbian is what it's called. The graphics card is not too great on it. There isn't any built-in Wi-Fi. And you'll have to use the command line some. It's also not as compatible with a lot of software as, a Windows or a Mac machine would do. It does not come with a screen or a keyboard or a mouse. You will have to provide your own screen or keyboard or mouse when you use it. But yes, you will be receiving your own Raspberry Pi 2 Model B. You're okay. The Raspberry Pi is just a microcomputer. It's basically, laptops are like all built in one, but if you have a desktop computer that has a tower, so it has a screen, a keyboard, and a mouse, the tower is basically what your Raspberry Pi is, but a lot less powerful. Or, the Raspberry Pi is less powerful, sorry. It's basically just a computer that is super ultra portable. And the last question I saw is, aren't some Charlotte Labs once a month? I do believe that some of the Charlotte Labs are. I think that they're on Saturdays, and that is for the folks that live a little bit farther away. I know that Winston-Salem has their labs in Charlotte. I'm not sure if it's once a month or not, but for most folks, you're going to have 2 labs a month. But every week you will have 2 webinar meetings. The question was, how customizable? It's once a month or Winston? Okay, good. Thanks for letting me know that. The Raspberry Pi is very customizable. If you're familiar with any sort of Linux machine, it's literally a Linux machine. So yes, you can add an animation or a sound for when you turn it on. I've seen some really silly stuff that folks have done to their Raspberry Pi when they use it. A lot involving fart noises. That was kind of funny. The other question is, do I live closer to Raleigh than Mr. D? Yes, I am in fact in Raleigh right now. Mr. Dubik lives in Charlotte, which is a good 2 or 3 hours away, so yeah. So I'll actually be meeting with the Raleigh folks. Everybody else will be with Mr. D. So I'm going to put your hands down real quick show of hands, if I can find the list. Who has not registered for Edmodo? Show of hands, raise your hand if you have not registered for Edmodo and added to a class yet. And if you haven't, it's okay. I'm not mad about it. I know it's the second day. But it's vital that you have an Edmodo account for this class. Edmodo is basically a virtual classroom. Again, this is a review for a lot of you. It's a virtual classroom where occasionally I will be posting cool engineering things or reminders for you. This is just good to have so y'all know what I expect. So a little bit later on, I will post the Edmodo group codes again in case you haven't signed up for it. Or you can always send me an email, which I will post in the chat. My email is saunders.yeot@gmail.com. So I'd probably write this down or something because I am always available to you via email. So later on, when we get into more complex stuff, if you're having any questions, definitely feel free to email me. Another good question. What exactly are cool engineering things? Mostly it's videos of cool things that I may find. Specifically, the first one I was going to post is that they 3D printed a jet engine. Like, they actually 3D printed it. While that probably seems sort of cool, they actually show you them doing it and testing it, and it actually works. Cool engineering things is stuff like that. Mr. D will also be doing the same thing in terms of posting information. Yes, yeah, I agree. It's some pretty cool stuff there. It's kind of wild what they can do with 3D printing now. My classes this summer got to see all sorts of castles and houses being built with them. How do they print it? It's a little bit weird how they do it. It's one of those things you have to see to believe. I don't know exactly how they do it. It's some sort of... What's the word I'm looking for here? I want to say magic, but I know that's not a good way to put it. Because a lot of the things that are engineered today are magic to me, an engineer. So don't worry about how it's done. I'll post it on Edmodo so y'all can take a look at it later. Question, are we going to make cases for the Raspberry Pis with the 3D printers? Definitely. The thing about the 3D printers, which I learned this summer, sometimes the printers are kind of funky, but I would really, really, really like to build cases with these 3D printers. It's possible. I've seen it work. The Raspberry Pi is basically just a circuit board, so it is kind of pointy and sharp. And the cases are always a lot of fun to customize and do what you want with them. So, I didn't see anybody with questions about Edmodo. Has everybody gotten a Gmail, or not Gmail, but a Google account? It doesn't have to be a Gmail account, but you do need to have a Google account. Seen a couple yeses. Show of hands who hasn't. Are you going to code in Minecraft? Yeah. You will be doing some. Gmail does count. Gmail is, you make a Google account by default. But in terms of coding Minecraft, you will be using Python to sort of hack/mod Minecraft a little bit. Some pretty cool stuff. Python is a programming language, which is very easy to get the hang of. So, yes, we will be using some Minecraft with the Raspberry Pi this year. So, have I heard of Pixelmon? I have not. Is it just a Pokemon clone? Pokemon mod for Mac? I have not, but I played one of the Pokemon mods before. Which one did I play? Doesn't matter. But still pretty exciting. Oh, for Minecraft. I have not. That's really cool. I thought you meant Mac. I don't have a Minecraft account, so I should probably look into that, shouldn't I? So anyways, I digress. We talked about what exactly an engineer does, which is using science and math to build machines and systems and general things like that. We discussed the perks of being an engineer, specifically A, money. You'll make some mad money. B, job satisfaction. Engineers do have a very high job satisfaction. And what was the last one? And C, the fact that most of the jobs, or half the jobs today that are being created are as a result of the new technology that's coming out over the past, 5-10 years. But a lot of jobs are also being lost as a result of technology, specifically in the automation sector. And so I discussed a little bit on the different classes of jobs. Notice that medium-skilled jobs, which is, not accounting, but office and administrative tasks, they've been replaced by technology. So especially if you're a woman, which are these nice yellow bars here, you're gonna have a hard time finding a job unless you find a field that you enjoy that's usually in the tech business. So, all my girls here, y'all have a ton of jobs waiting for you. You just gotta work for them. And yes, Matt, what's your name? Matteo? Apologies for if I mispronounce your name. But yes, I will. So I see a hand raised. Is that a question or just acknowledgement? Alright. continue then. So, oops. Yes, this image here, I'm not sure if I got to this last class or not. This is an assembly line, a completely automated assembly line. So, in the past, these robots would all be actual workers. They would be hand assembling these parts. I think it's a car, it looks like a bumper that's right there. They would have to assemble these parts, but now robots are doing all of it, probably more accurately and with fewer issues than if humans did it. So, if you want to make sure you have a job, you should definitely be looking in the tech field, or any sort of STEM field, STEM being science, technology, engineering, and mathematics. That's where all the jobs are. So at this point, what I'm going to do is discuss a little bit about the engineering method and the scientific method. Obviously, they are very closely related, but there are a couple of key differences between the two. So the scientific method is essentially what you will be learning soon in your math or your science classes, if you haven't already learned them. The scientific method is a way to find something out about the world and figure out why it happens definitively. So the first step of it is observation. So a couple hundred years ago, they didn't know why the sky was blue. So let's say I'm a scientist and I say, the sky is blue. Why is it blue? That would be an observation. Hypothesis is making not so much an educated claim, but making a guess as to what you're trying to test. So you're trying to figure out why the sky is blue. You would say, okay, well, the sky is blue. I don't know why the sky is blue. Let's just say that it's because the light's reflecting off the ocean. That's not really it, guys, but bear with me here. So in the next step, you would experiment. You would say, okay, well, if the sky is blue because of the reflections of the ocean, what if I go very far inland where there is no ocean for the sky to reflect off the sea or something? So you actually have to try something. You can then analyze data, saying, okay, well, the sky is still blue in the center of the country. At this point, you don't necessarily go to your conclusion. If it's obvious that the experiment contradicts your hypothesis, you have to make a new hypothesis in a new experiment until you find sort of a decent reasoning for why the sky is blue, which for the record is caused by Rayleigh scattering. The atmospheric gases reflect the green and the red light. Not reflect, they absorb the red and the green light and reflect the blue light, which is why our sky is blue now. So I see a question. Yeah, some pretty cool stuff, but they didn't know that back then, so scientists had to use the scientific method to do it. So you can then draw a conclusion from this, and it's not like it's set in stone once you draw a conclusion. Your peers, your friend scientists, have to duplicate the results of your experiment for a hypothesis to be found true or false. So that's the scientific method, but the engineering method is a little bit more streamlined, I guess is a good word for it. The engineering method isn't so much about testing a hypothesis, it's more about creating an object to solve a problem. So the first step is to research it. Say that you're standing on top of a mountain, and on top of the mountain next to you, there's an ice cream shop. And you're really, really lazy, you really want some ice cream. You're not about to go all the way down the mountain and all the way up the other mountain to get to the ice cream shop. Obviously, there is a need to build something to solve the problem. From there, we plan. Okay, so I see a question real quick. Yeah, there's a problem, and so we're going to build something to solve it. That's essentially what I'm talking about here. The planning phase involves brainstorming. It involves saying, well, how could we fix this problem? We can build an enormous rope swing, but what are we going to hang it off of? We could build a zip line, but it only goes one way. We could build a bridge. Huh, that sounds like a good idea. Let's build a bridge between the mountains. All right, so good statement. Wouldn't it be easier to walk there than to build a bridge or something? Let's just pretend that this person is really smart but incredibly lazy. Like, he's not about to just walk somewhere. It's a mountain we're talking about, like Mount Everest. So it would be easier to walk there, but what if you and 5,000 of your friends wanted to go to the ice cream shop? Not everybody is able to walk, or hike up enormous hills. I digress, sorry. It's a little bit too specific for this example. The next step is to prototype, which is building models, both physical models and computer models. We have to make sure that this bridge is going to be sturdy. We have to make sure it's going to be able to withstand the conditions down on the mountain. Just like with the scientific method, though, if the prototypes do not succeed, we have to go back into the planning stage and continue in this cycle until we reach the commercialized stage, which means the stage where we actually build it and have a successful bridge. So this is a very drawn out explanation of what I just did there, and the rest of the slides are not very relevant. So before I go on to what we're actually going to be doing today, which is learning a little bit of HTML and maybe getting to building our Google site, does anybody have any questions on what I expect, or scientific and engineering method, or what is expected of engineers? Any questions about that? I'm going to give you a second to ask me a question, if you do have one. Okay. And definitely feel free to ask me questions at any time. I might not address them immediately, but I will get to them. So finally, after all the intro stuff, we get to our first little bit of engineering. We are going to start with an introduction to HTML and Google Sites. HTML is essentially a very basic sort of programming language that lets you build your own websites. Now, there are definitely there's definitely more than just HTML, but it's a little bit more complex, so we're going to stick to something a little bit simple now. So, as I said, we're going to set up and build your first web page. We are going to learn what HTML is and how it works. We're going to prepare your HTML editor and web host. By web host, in this case, I really just mean your internet browser. And then, probably not all of today, but we might get a little bit into building our first very, very basic web page. So again, we're creating this Google site as our digital portfolio. We want to be able to demonstrate our learning to both ourselves and to people in the future who are interested in what you've done in the past, to show off your work in projects and to show others how awesome you are. Just the fact that you all are taking an extracurricular class on something technical like engineering topics already proves how awesome you are, and I know that, but not everybody else does, so just bear with me. You definitely will be wanting to work with this digital portfolio as the semester goes on. So we're using Google Sites, A, because it's free, let's be real. Free software is wonderful because money is not cheap. But Google Sites is nice because you can create a website with just a couple clicks. You can customize it as you want. There are already some templates made by Google, and you can share it to whomever you'd like. Now, because y'all are younger, how old are you guys? Probably 13, 14, somewhere in that area, I would assume. 12. Okay, so you're somewhere between 12, 13, 14, maybe 11. And that's wonderful, and it's also a wonderful time to teach you some stuff about internet safety. The internet is a wonderful tool. I love the internet. I spend way too much time on the internet. But if you're not careful, bad things can happen. And as a result, I'm going to do a quick and boring little lecture on internet safety. When you put things on the internet, don't share it with, or don't share things about you on it. So don't talk about your family, don't give them your last name. If you share any information, it makes you easy to identify, and that's not okay. We don't want that. Similarly, do not share your full name and address or phone numbers or your house, anything like that. Again, if somebody bad finds this, I don't want to know what happens. Particularly if you are under 13 years old, but I would say probably for everybody, tell your parents about your Google site that you're making. They will also be excited to see what you want to do, or what you've been doing in class rather. And I'll show you how to do this, but you can make your site private or give link access only, meaning that only you can access it, or people that you give the link to can access it. So keep in mind, anything on the web can be seen by somebody. There's all sorts of hacks that have been going on with like PlayStation. Trying to think of anything that's happened recently, hack-wise. But regardless, somebody can find it if they want to try hard enough. Swatting fee? Did something happen with that? Anyways, keep that in mind. Notify your parents of anything sort of questionable. Not so much that'll happen with your site, but if you're sort of confused about a pop-up that's a little bit sketchy. Oh, for example. Yeah, exactly. And definitely don't put pictures of yourself on the site without your parents' permission. There are ways to protect your anonymity, even with pictures. I would probably just stick to pictures of the projects you're doing on the site. So that said, apologies, I know that's boring stuff and probably common sense to you. Not common sense to a lot of people though. Anyways, we're going to talk about HTML. So obviously I have this wonderful slide with a bunch of things about HTML, but has anybody actually used HTML before? Anybody familiar with HTML? Alright. So I see a couple people with their hands up. I see a couple people that are just like, I've never touched it before. And either way is fine. If you're familiar with HTML already, this might seem like a review. If you're not familiar with HTML, this will be pretty cool stuff. Regardless, this is going to be a wonderful review. So HTML is essentially the building blocks of your websites. You've used it a little bit? Yes, I've never used it extensively, but if you can do a little bit of HTML, it's very easy to apply that knowledge to a large base of HTML. So HTML stands for Hypertext Markup Language. Oh, you made a website already? Nice. So yeah, this will definitely seem like a review to you then. HTML first appeared on the internet in 1991. For anyone that's counting, that's 24 years ago. Way before a lot of you were thought about. It became a global standard for websites in 2000, meaning that every single website on the internet today uses HTML in combination with other website editing softwares, which I'll go into later, but we won't be going into later. And it's gone through several different versions, HTML5 being the newest version. It came out and became the standard in October of 2014, so it hasn't been out for too long. I do think some of the slides in this PowerPoint will say that it's using HTML4 instead, but for this level, it's not too important what we're using. Just know HTML5 is what we're looking at. This slide, again, like I said, is old. It says that HTML5 is not yet the standard, even though it is the newest version. It is now the standard. This slide is old. So HTML works a little bit strangely, unlike what you'd expect. You start with a document with a bunch of HTML code. So it's just a bunch of brackets, what it looks like here. We'll be writing this later. The HTML document is then stored on either HTTP or servers for the most part, or you can do it locally, which we'll be doing in here. It gets read by your browser when you try to access these servers, which is then seen by you, Mr. Happy Computer Kid over here. Or Miss Happy Computer Kid, whatever. So HTTP, the Hypertext Transfer Protocol, is the baseline for the internet and the client-server interaction, meaning how your computer and YouTube talk, how your computer and any website in the world talk to each other. The servers store all of this information, and as it says here, pictures and videos, but the servers themselves do not translate any information on an HTML file. All that these servers have is this sort of weird looking text stuff. You think you type that in before a URL? You most definitely do. And actually, specifically for this Google slideshow I'm doing, this is an HTTPS, which is Hypertext Transfer Protocol Secured. Yeah, that's exactly it. You're just calling that, essentially. You're calling it saying, hey, I want to access this. Let me access it. And that's why the HTTP is in front of all your websites that you go to. So from the server, the browser that accesses this information actually translates the file and makes it look good. So say I go to Edmodo here. All I'm doing is telling my computer to connect to Edmodo's servers. From there, when I connect to it, the browser sees all this stuff, and I will show you actually right now by right-clicking and viewing page source. This is the HTML code to write that web page. That's a lot of stuff, isn't it? Do you think it would be fun to read through this and use the internet with this method? No, not at all. Your browser, so Chrome, Internet Explorer, Firefox, Safari, Opera, whatever you may be using, is what makes it look like this. It's why if you access something in Internet Explorer and then try it again in Chrome, it might look different. So this is why some browsers are a little bit quicker than others. That's why one will be better at some things and worse at other things. My personal favorite browser to use is Chrome. I haven't used the new Windows browser yet, though. I've heard good things about it, surprisingly. But you can use what you like. For some software, I will ask you to use Chrome specifically for. But you'll need to worry about that for now. So as I showed you a second ago, obviously writing the HTML out by hand is not going to be easy. That's a whole lot of stuff there, isn't it? It's just boring and long and bleh. So professional web developers use software that lets you edit it a lot easier. This one right here actually is called Dreamweaver. I know people that use a whole bunch of different other ones. I'm trying to think specifically of one. Doesn't matter because we won't be using them. But these programs, CSS is actually just like, it's not an editor. It's a different way that you can change how your code looks. JavaScript's another one sort of like CSS. Not sort of like it, but it works on HTML. So anyways, you can actually preview these pages using these nice softwares before you actually look at them, which you can't do with our methods, but that's okay. You use Java for web pages or JavaScript? So unless you're building little games or something, I doubt Java would be very good for web development. I don't even think it would work for web development. That said, Java is a wonderful language, and if you know Java, it'll be very easy to learn HTML. So while they have these nice, wonderful editors here, there is one nicer thing about using HTML. Oh, use it to code your Minecraft server. Yeah, and actually you can use Java proper to code on Minecraft. We actually offer a class in the summer to do that. Exactly, exactly. You can use JavaScript to make your website interactive. We're not doing JavaScript in this semester's class. We did it last semester, but JavaScript is a lot of fun. And when we do code combat, though we're doing it in Python, there's also an option for JavaScript. And if you want to do that in your free time, I certainly advocate that. So the good thing about HTML versus these crazy editors that the professionals use is that we can write HTML in text editors. So if you're on a Windows machine, I would like for you to open up Notepad. If you are on a Mac, I want you to open up TextEdit. So for Windows machines, I only have 8. What I would do to open Notepad is go to your search and type in Notepad. I think on Macs you can click on the Finder and look for it there. But what I want you to do right now, I want you to open up Notepad or TextEdit. When you successfully do this, I want you to raise your hand. And I'm not going to continue until I do see everybody's hands raised, meaning you have either Notepad or TextEdit open. Is anybody having trouble opening this? All right. Okay, wonderful. Looks like everyone's got it. So those on Windows, y'all are great if you have Notepad open. It's literally just this guy here. You can type, blah, blah, blah. But, okay, I see a question real quick. So no, I will be using just normal Notepad for this one. For those of you that are on a Mac, you probably see something that looks a little bit more like this. It has a whole bunch of font options and like a ruler. Do not use this to build a web page. You will need to click on the Format menu and select Make Plain Text. So those of you on Mac, I want you to do this. I want you to click on Format and then Make Plain Text. And I want you to raise your hand if you have done that on Mac. Those of you on Windows are having a grand old time. You don't have to worry about that. Alright, I'm going to continue, but only because I don't know what operating system you're using. please, if you haven't done this and you're on a Mac, please stop me now. Okay. If you do this correctly, your notepad will look a lot like mine, and I do see a question here. Alright, good point. Elijah's saying if you are on Linux, because I did not include that, I just didn't think that anybody would be using Linux, good for you though, use LeafPad. I think you might be alone in the Linux use though, but that's pretty impressive. So you'll have something very basic that looks like this, which we will be able to start our code on. So as I've sort of hinted at, HTML is literally just a whole bunch of text, and it's not translated until it hits your browser. Oop. Which is a compiler for HTML files. So if you're not familiar with programming, you can program, you can write all the code you want, but the code's not going to do anything useful unless you compile it. The compiler changes for whatever code you're using, but the compilers for HTML is your internet browser, which is wonderful. And as a result, you don't need anything fancy to code in HTML and to see your web pages in real time. It's pretty fancy. So finally, we're going to do some HTML. Those of you who have used it, just bear with me. It'll be a good review. Hopefully, I at least taught you something in the past couple slides. So the structure of HTML, I showed you a little bit of it earlier by viewing the page source, but HTML has discrete keywords called tags, which we keep within these angled brackets. So every single tag that you'll be using will be surrounded by these brackets. Now most of the tags you will be using will have both an opening bracket, or an opening tag rather, so this is the entirety of it, and a closing tag, which is denoted as the same as the opening tag, but with a slash, a forward slash I think it's called, in front of it. But not every single tag does have a closing tag to it. I'll show you that later. But for the most part, you'll need to open and then close a tag when you're done. So the vast majority of these tags are going to be paired, meaning you'll need an opening and closing. This single tag here is just half of an actual piece of code. You have to include both for it to be a successful code. Now, unpaired tags, specifically those of comments, which you can see right here, and page break is one, sharing a link is sometimes one. Unpaired tags, you only need that one. Comments is what this is here. Comments are for the programmer's use only. So while the code does something to your web page, this comment won't. It's literally just for you to say, this is what this piece of code does. This is why it's here. Don't delete it. So you've got your text editor open. What I want you to do is type what you see on your screen right here. And to help y'all out, I will probably, let me resize this. I will write this bigger so hopefully you can see it better. With HTML, you have to make sure that you type everything literally exactly as you can see it here. So let me see if I can make this bigger so you can see it better. Hopefully that'll work. I want everybody to be typing this into their text editor right now. Ooh. So I want you to type this, and when you're finished, please raise your hand. Wow, you're a quick typer. You might have beaten me there. Can I copy and paste it to you? I will, but I do highly recommend that you all work some on typing. I did send it to you in the chat. Hey, no problem. I guess I'm just not a very good typist, so. Alright, cool. So just keep your hand raised until we get everyone there. No rushes, no rush. If anybody's familiar with HTML, do you want to tell me what this piece of code is going to do, if you're familiar with it? It will make a web page, but it won't be too much of a web page. It's literally just a blank page. It's because we haven't added anything to it yet. We've only added our tags. We haven't put any information into the file yet. But it is a start. You're right. So this probably looks like a whole bunch of nothing to you, if you're not familiar with it. So what I want you all to do, I want you to save your file as. So go to File, Save As, or whatever the equivalent on Mac is. I want you to, save your file to a place where you can find it easily. Okay, I'm sorry. I'll slow down. Slow down. And thank you guys, actually. That is a good point. If I'm going fast, please tell me. So I'm just going to have you finish that up and save it as for now. Alright. Like I said, in the future, I will be conducting some polls asking you how my pacing is. Pacing being if I'm going too fast for you or I'm going so slow that you're out of your mind bored. Just to see how I'm teaching and if I can speed up or not. Since it is the first couple days of classes, I have not been. But yeah, so I'm going fast, let me know. So I want you to find a place to save it that is easy to remember. I'd probably save it on your desktop maybe. And I would probably save it as, just for consistency's sake, let's save it as index.html and save as file type all files. Please raise your hand once you've saved your file type, or saved your file in a convenient spot, saved it as index.html as type all files. Well, now you're confusing me, sending me mixed signals, telling me I'm going too fast, going too slow. Keep in mind there's only so much I can do. It's sort of based on the speed of everybody. Alright. ready to move on, please tell me no if you're not. Exactly. See, I'm getting fast, I'm going slow, I'm getting good. It's a consistent thing that happens. There's not a good way to standardize it for everybody. But if anybody's not there, please tell me now. Please send me a question or something in the chat box maybe. Alright. What I want you to do is navigate to where you found, or to where your document saved. For me, it is on the desktop. I'm going to actually choose a default program since it's probably going to open in Internet Explorer, and I'm not okay with that. I'm going to open it in Chrome. And it loaded, but it's nothing. It's literally a blank page, just like expected. That said, y'all now have made your first web page. Hooray! Not first necessarily, but first in this class. Obviously, this is a local file. Do you remember where you saved it, Una? Did you save it on your desktop? Your first web page said loading? Oh my gosh, that's evil. I would have probably spent very long waiting for it to load too. I'm not sure where it would be if it's on your desktop. If you save it to your desktop, that is. You might need to save it elsewhere. So obviously that's not very fun yet. And double click it, it'll open in your browser, yada yada yada. And let me show you what's going on here, because all of this stuff does something even though it doesn't look like it did on your web page. It looks like you got an unpaired tag. Why do we put all this in there? Why didn't anything happen? Yada yada yada. This first line here, the doc type, it's very important because it tells your browser, hey, I am an HTML file. Read me as an HTML file. Including this, make sure that your browser reads it as an HTML file. I'm going to say that a million times. But you do not need to pair this tag. It's one of those few that doesn't have a friend. Notice that head does, notice that body does, even HTML does. Again, the unpaired is going to be kind of infrequent, but you'll use it occasionally. With the exception of that doc type tag, the rest of your code is going to be contained within the HTML brackets. Again, it's saying, hey, this is HTML. This is where the code starts. This is where you start reading it. This is where it ends. This head tag right here is kind of an interesting tag. Oops. It tells you the information about the page. It'll tell you the title of it, which will appear, on the top of your screen. It'll tell you the style, or sorry, you can tell it what the style is. Okay, you did find it? And you saw nothing, right, Una? Nothing at all. We'll get there, though. But here's where you can change the style for the entire web page. If you want to make it white or red, or we'll add stuff to that later, don't worry. Body will contain everything else in your web page, essentially. Everything in the body, so it's going to be where your text is, where the majority of your web page is going to be contained within. And so again, notice the end tag for HTML at the very end, of course. So the head tag specifically contains information about the entire document. That way you can do some formatting, like font, background, colors, adding scripts to your page to make something happen when you load it. But we're not going to do too much of this right now. We'll probably get to that later. We're going to be using the title tag next, which is what makes it show you the title of your web page. So within the two head tags, I want you to type in, oops, I am so bad at typing sometimes. I want you to type in title, and I want you to name your web page something cool. I'm not very cool, so I'm going to be boring. But remember, when you open the title tag, you'll need to also close the title tag. So go ahead, raise your hand if you have done this. I use the hand raise as sort of an indication on how far you all are, in addition to the polls, which I will be doing. You'll name yours generic name. Perfect, it works, doesn't it? This HTML is for your reference specifically, so you can literally name whatever you want, but I wanted you to do something cool because who doesn't like cool things? Your file erased everything you had typed. Alright, go ahead and hit both Control and Z on your keyboard if you're on a Windows, or Command and Z, Z as in like zombie, if you're on a Mac, and it should come back. And the question there was, my file erased everything I had typed. So I'm just having you undo. It didn't do it. Alright, what I want you to do then is go ahead in our chat window and just recopy the HTML code that I sent you. And then add this wonderful tag to it. So when you do this, what do you think what's going to happen if you save it and try to load it in your browser? You called your webpage something cool? I like it. I like the literalness. Let's do it. So I'm going to go ahead and save this. And let's see what happens when I try and open it. It undoes everything. It shouldn't undo everything. What it should do is, when you open your page, it'll literally have the title of what you did and nothing else on it. What might be happening, you want to make sure that nothing is highlighted, because if you highlight something and then start typing, it'll erase it. Otherwise, what I want you to do is just go into the chat and copy and paste the piece of code. You have to use Python for a game, they might as well make you type in comma for a comma. Yeah. But as you get into more complex programming languages, you won't even think about doing that. It'll be common sense baseline for you when you get a little bit farther along. So let me bring this back up. If you do that correctly, you're just going to see a blank page with the title called whatever you called it. With that said, it is about to be 5 p.m. Oh, you're fine, Cameron. I'm not upset about it, about your hand being up. That said, it is now 5. And so that signifies the end of class. So does anybody have any questions on anything we did today? To those who are familiar with HTML, I appreciate you sitting tight with me here, since it should be some review. do you need to bring your computers to the lab? You will not. We will either be providing you computers if we need them, but normally we won't need the computers. In this class, we will not be learning Java. We did do Java last fall, but we tend to do a couple of different programming languages based on which semester it is. This one's going to be Python this semester. Alright, if you don't have any questions, you are free to head out for the day. I'll be on for just a couple moments to answer any questions. Thank you guys so much for coming out to the webinar. Remember, if you have any questions, you can either email me or go to the YouTube channel. Yeah, no problem. I will talk to you next Wednesday, guys. Remember, no lab on or no webinar Monday. Next Wednesday. He was here, but he's no longer here. He's already left. Yeah. He was in class, but he's not anymore. He already left for the day. Yeah, no problem. If there are no more questions, I'm going to head out, and I'll talk to y'all next Wednesday. Have a good one, guys.